Hello everyone, welcome back to our lecture series of complex analysis. In this lecture, we will discuss contour integrals. In the previous lecture, we talk about contours and as I told you कि जब भी हम complex integrals को discuss करेंगे, then in that scenario, contours has their own important role. Okay. So let us start this lecture by writing the definition of integral and before that let us identify कि हम contours integral को किस तरीके से denote करेंगे. Okay, so I'm taking some supposition and then we'll write the definition of contour integral. Okay, so let we are having a function let f be a complex valued function of complex variable z. Okay, and let c be a contour. The moment I say this is contour, that means this is a piecewise smooth curve. Okay, c be a contour joining the point z1, z equals to z1 and z equals to z2. Okay, so in the scenario where complex plane is going to be discussed, वहां पर c एक contour है जो कि z1 से z2 point को join करता है in the complex plane. Okay, now how we will denote the integral in complex. Okay, then first of all we are having the notation. How we will denote the complex integral. Okay, then the contour integral of f along c is denoted by we will write c this integral and then we will write c. So this will denote the contour and with the variable z. Okay, so this is the contour integral or the integral of this function along this contour c. Okay, so this is the notation. Now if this integral is independent from the choice of the path along which we are joining the z1 and z2, जो भी हम पाथ z1 और z2 को ज्वाइन करने के लिए चूज कर रहे हैं, अगर ये इंटीग्रल उस पाथ से इंडिपेंडेंट है, देन दिस इंटीग्रल कैन आल्सो बी रिप्रेजेंट in the following form. So second, now let me write this is first one and then if the integral is independent of the choice of the contour taken between two fixed point z1 and z2, then the integral can be given as then the integral can be given as we are integrating from z1 point to z2 of this function fz dz. Okay, so this is the integration of this function from the point z1 टू Z2। ये हम कब लिखते हैं? जब Z1 और Z2 को ज्वाइन करने वाले पाथ की चॉइस से ये इंटीग्रल इंडिपेंडेंट हो, देन वी कैन राइट this integral in this form. Okay, now we know how to represent the integral. So at this moment we are going to define the contour integral. Okay, so now we are writing the definition of contour integral. Definition, and this definition is going to discuss contour integral. Okay, so how will we define this? Okay, so let the equation, which equation? Z is equals to zt, where this t is running from a to b. This t is real variable. Okay, the moment we are introducing the ordered property less than or greater than sign, that means that will be a real number, क्योंकि complex number में तो order property hold ही नहीं होती है. So let the equation is, this is the parametric equation. Okay, so let the this equation represents a contour C. Okay, and this is extending from a point. Now what was that point? Z1. Now Z1 is the initial point, so initial point will be will be referenced to this t equals to a. We are starting from a and ending with b. So t को जब हम a पुट करेंगे तो हमें Z1 मिलेगा, और जब t को हम b पुट करेंगे तो हमें Z2 मिलेगा, and that contour is the same path which is joining Z1 and Z2. So Z1 is nothing but the value of this particular equation at t equals to a to the point Z2, and that is nothing but the value of this function Z at b. Okay, this is our first supposition about the contour. Now as you see that contour integral, both contour integral depends on this function and as well as this contour. Okay, तो जब भी हम complex analysis में इंटीग्रल को डिस्कस करेंगे तो वहाँ पर फंक्शन क्या है ये तो इम्पोर्टेंट है ही, जैसा हमने रियल एनालिसिस में देखा था, बट यहाँ पर कॉन्टूर क्या है उसके बारे में भी हमारे पास एक इनफ इंफॉर्मेशन होनी चाहिए. अब इनफ इंफॉर्मेशन का क्या मीनिंग है कि कॉन्टूर जो है वो किस सेट ऑफ पॉइंट को रिप्रेजेंट कर रहा है और इसका ओरिएंटेशन क्या है, ये पॉजिटिवली ओरिएंटेड है या फिर नेगेटिवली मीन्स क्लॉकवाइज डायरेक्शन में है या एंटी क्लॉकवाइज डायरेक्शन में. हमने प्रीवियस लेक्चर में देखा था कि दो कॉन्टूर का सेट ऑफ पॉइंट सेम हो सकता है, बट जैसे ही हम उनका ओरिएंटेशन डिफरेंट करेंगे तो वो अलग अलग कॉन्टूर्स को रिप्रेजेंट करता है. ठीक है, तो यहाँ पर ओरिएंटेशन एक इम्पॉर्टेंट रोल प्लेइंग चीज है. ठीक है, so now this is about the supposition of contour. Now we are going to write some supposition of the function. So we assume that f at z of t, that was f of z, now z is nothing but z equals to zt, is piecewise continuous on the interval which interval a less than equals to t less than equals to b. Now this function is nothing a function of this t. राइट. सो जब पहले हम जब इसको डिस्कस कर रहे थे, दैट इट वाज कॉम्प्लेक्स वैल्यूड फंक्शन ऑफ कॉम्प्लेक्स वेरिएबल z. नाउ वी हैव ट्रांसफॉर्म्ड दिस z into a function z of t, where t is some real variable. So on this basis of this representation, now this function f becomes complex valued function of real variable t. Okay. And suppose we are having this one, and also we are supposing कि जब भी हम यहाँ पर t की वैल्यूज को पुट करेंगे, तो जो हमें z की वैल्यूज मिलती जाएंगी, उन z की वैल्यूज को जब हम यहाँ पर इंसर्ट करेंगे तो हमें मिलेगा f of z. So f of z और f of zt will give the same values, or we can say the same set of points. Okay. So we assume that this function is piecewise continuous on this interval a to b, closed interval a to b, right? Then the contour integral of fz, look at the language, the contour integral of fz along the contour, which contour? Along the contour C is given by this particular equation. So integration along the contour C of this function f of z with respect to the variable d z. Okay, sorry, z. Now this will be equals to, because we were starting from the point A to the point B, and then value of this function calculated along this real variable t, and then derivative of this z along t. Okay, so this is the definition of contour integral when we are having the explicit representation of contour. Okay, so this is contour integral. Now the moment we say C is contour, okay, let me identify one thing. When C is contour, then this is piecewise smooth curve. Now this smoothness gives us Z t, and that zt we always say कि ये zt हमारे लिए पीस वाइज कॉन्टिन्यूस फंक्शन हो, तभी तो हम इसे कॉन्टूर या स्मूथ बोलते हैं. स्मूथनेस का डेफिनेशन ही यही है कि फर्स्ट ऑर्डर जो डेरिवेटिव है दैट इज कॉन्टिन्यूस. अब जब ये कॉन्टिन्यूस है तो इसका मतलब यहाँ पर जिसका हम इंटीग्रेशन करने वाले हैं वो फंक्शन कॉन्टिन्यूस फंक्शन है, ये एक पीस वाइज कॉन्टिन्यूस फंक्शन है. तो जो भी इंटीग्रेशन होने वाले फंक्शन है वो पीस वाइज कॉन्टिन्यूस फंक्शन है. और हमने रीमान इंटीग्रेशन में पढ़ा है कि जब भी हम रियल वेरिएबल के अलोंग किसी भी फंक्शन का इंटीग्रेशन कर रहे हैं तो वो फंक्शन अगर पीस वाइज कॉन्टिन्यूस है तो इंटीग्रेशन एग्जिस्ट करता है. तो smoothness of this contour will provide us the existence of this right hand side integration. Okay, so that its smoothness ensures the existence of this definition. Okay, now based on this definition we are going to discuss some significant properties of integral, but before that let us have a look on the variety of this contour C. Okay, what do you mean by the sum of two contours, negation of two contours at all? Okay, so this is the definition. Now we are going to discuss the negation of the curve, or the let me write the curve, or more precisely the contour minus C. Okay, that what is that minus C? ठीक है, so let C be a contour given by, this is very important one. okay, यहाँ पर जो हम डिस्कशन करने वाले हैं, जब हम कॉन्टोर्स इंटीग्रल को आइडेंटिफाई करेंगे, उसके एग्जाम्पल्स करेंगे, तभी डिस्कशन बहुत इंपॉर्टेंट हो जाएंगे. ठीक है, C be a contour given by Z equals to zt. Of course, this zt can be written as xt plus iota yt. Okay, you can always understood that. Let me write. This is for the understanding purpose only. Okay, xt plus iota yt. Okay, that zt is nothing but like this. Okay, where this t is running from a to B. This is our contour. Then what is the, that minus C? If we are having C as this form, then what is minus C? Then, then the contour minus C is given by Z is equals to Z minus t. That minus sign is very important. Okay, where now this t is running from minus b to minus a. Okay, so this is a negative of the contour c. अगर अब हम इसे देखेंगे ज्योमेट्रिकली कैसे रिप्रेजेंटेशन इनका होगा, सो लेट अस आइडेंटिफाई दैट आल्सो. सपोज दिस इज आवर कॉम्प्लेक्स प्लेन and this is our curve C. Suppose this is our point Z1 and this is point our Z2. So this point is Z1 and this point is Z2. Precisely ये जो Z1 point है that is nothing but Z of A and that Z2 is nothing but Z of B. That is the supposition or the representation give us. Now let me write what is negation of this curve C. So again that same curve जो भी representation है वो हमारे पास same ही होगा. But since in the previous one we were starting from Z1 to Z2, so we were like going from Z1 point to Z2 point. Okay. Now that minus c representing the curve which is coming from Z2. देखिए यहाँ पर जब हम t को स्टार्ट करेंगे so t की इनिशियल वैल्यू माइनस b है. So when we insert minus b in place of this t, then we will have z of minus b. That is the initial point of this contour is nothing but z of b. And when you come at the last point, then this is minus a. और जब आप t की जगह माइनस a पुट करेंगे तब आपको z of a मिलेगा. That was the initial point of that contour C. But in case of minus C, that ZB is initial point and ZA is the ending point. So let me write, suppose if this is our Z1, this is our Z2, that is Z1 and Z2 are still same. But now this is Z2, Z2 point कौन सा था? B point था, that is Z of B and that was Z of A. But now the scenario is different. Now we are coming from Z2, that was from the point Z2 to Z1. Okay, so here you can see कि जब हम माइनस c की बात करते हैं तो सेट ऑफ पॉइंट सेम ही है, बस उसका ओरिएंटेशन बदल जाता है या फिर कहे ऑपोजिट हो जाता है. In the previous case, we are considering the curve from Z1 to Z2, but in case of minus C, we are considering the curve from Z2 to Z1. Okay, so there is the only difference between C and minus C. So let me mention this thing here. This is the curve, the contour C, and this particular figure is. And this figure is about the contour minus c. Okay, so this is how we are identifying the contour.